So, ciao tutti, hi everybody, good morning or good afternoon, depending from which part of the planet you are currently attending this session. I'm extremely happy to be with you here today, and you should be too, as this is the Data Saturday #1, and I wish to Data Saturday Pordenone many more editions in next years, and hopefully see you on site, not just virtually. So we are definitely going to be part of the history. Today, I want to talk about Power BI internals, examine how your data is being stored, queried, and brought back to your report, to your Power BI report. Finally, when we absorb theoretical concepts of Vertipack, I would like to share with you some best practices to keep your data model in optimal condition. And I would like to show you a real-life example how sticking with those best practices can help you build an efficient Power BI data model. I believe it's quite important topic from many perspectives, and I really hope that you will enjoy the session and get some useful takeaways once we are done. At the very beginning, big thanks really to all of the sponsors. As you might assume, it's really hard to keep the pace in these, I would say, challenging times, and those folks from companies you see on your screens put their resources, their effort in supporting the event. Therefore, once again, big thanks to all of the sponsors. Before we start, let me just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last almost 5 years, I live in a beautiful city of Salzburg in Austria, where I work as a business intelligence developer in company ITSP services. Living in Salzburg was the reason why I've chosen my nickname, Data Mozart. As you probably know, Salzburg is worldly famous as birthplace of Wolfgang Amadeus Mozart. Therefore, I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. You can find me on the web. I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter, so feel free to connect if you like. A few more sentences about me. I have multiple year experience working with different data products, predominantly Microsoft Data Platform, starting with SQL Server, then continue with analysis services, multidimensional, SQL Server reporting services, integration services, and most recently, if you consider last almost 4 years, as recent with Power BI. I'm also a Microsoft certified trainer, and privately, I'm a true football and Barca fan, as you can conclude looking at the photo on your screens. What should you expect from today's session? Well, I like telling the stories, so don't expect like a normal session. I want to tell you kind of a story about a wonderful tool called Power BI and the engine that makes it so special. So in my story, you will be a real hero, and our villain will be non-optimal data model, which causes problems to our friend Vertipack not to work in most efficient way. As in most stories, heroes win in the end, of course. So you will see how to overcome challenges brought to us by evil data model, resolve different issues along the way, and finally make your Power BI development a real fairy tale. Therefore, make yourself comfortable, take a seat, grab a coffee or some other refreshment, and listen to my story. So I guess you all know story about Titanic. If you don't know, you should definitely watch the movie with Leonardo DiCaprio and Kate Winslet. Oh wait, you already watched it. Who hasn't? I mean, Titanic was the most powerful, most beautiful, most everything. So largest ship of all the time and brilliant piece of human creativity. But Titanic's story ended almost before it started. So after only 4 days of voyage from Southampton to New York City, Titanic hardly hit one of the many icebergs in the Atlantic Ocean. And at first look, it didn't seem like something that can transform the greatest engineering achievement into a historical tragedy. However, Titanic didn't sink because it hit tip of an iceberg. So the main culprit was under the surface in the cold ocean water, where the largest part of this iceberg resided. Now you're probably asking yourselves what on earth the story of Titanic has with Power BI. But if we think a little deeper, we can think of Power BI as an iceberg in cold ocean's waters. Tip of this iceberg is your Power BI dashboard or the report itself. And I mean, that looks really beautiful, like a snowy mountain straight in the middle of the water and under this awesome blue sky. But what most people don't know, or at least don't see, is that the real thing is under the surface. So the biggest and strongest part of this iceberg, which provides stability and steadiness of the visible part. And this underneath part consists of multiple individual but still cohesive parts which enable above the surface part to stand strong and shine. As I said, there are multiple individual portions down there. And if you stop and think for a moment as a Power BI developer, you will see different concepts, different architectures and techniques that makes your Power BI dashboard shine. If you don't understand and apply those concepts on the right, such as data profiling, data modeling, and data shaping in a proper way, your Power BI report will experience the same fate as Titanic. Same applies if you don't dedicate deserved attention to architectures and techniques on the left. So always keep in mind that all these, but also, of course, many more core concepts is what enable your Power BI dashboard to perform in the most optimal way. Therefore, never underestimate the importance of understanding all those, let's call them invisible things under the surface. Today, we will focus on learning and understanding VertiPaq engine, but you should also spend your time learning other key concepts listed here. In the end, you can create Power BI reports that work without knowing any of these underlying concepts, but there is a huge difference between Power BI reports that just work and Power BI reports that work efficiently. Now, in order to follow the story, you need to have some skills before you start. For example, you can't read the book in Italian if you don't know Italian, like me. So we are talking about prerequisites. And in regard to this session prerequisites, I need to stress a few things. First, this is a 300 level session, which means advanced level. So I will assume that you have some, not just basic, but intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic understanding about relational databases, their structure in terms of how data is being stored in the database, and of course to be able to distinguish between rows and columns. Of course, knowledge of Power BI is also necessary to follow along, because I will often refer to some things related to Power BI development that I assume you are familiar with. So as we agreed that I'm telling you a story, I mean, we didn't agree, but I hope you're fine with that. I intentionally avoided calling this part agenda. Instead, let's think of it as the contents of the book. So what's in for you today? We will learn what is VertiPaq, how it stores the data, what kind of algorithms VertiPaq applies to compress the data, and how we can help VertiPaq to build an optimal data model for us. Finally, we will need to leave our book on the shelf, pick our toolboxes, go out, get our hands a little dirty, and dig deep under the hood of Power BI. During the demo, I will show you on a real-life example how to reduce your Power BI data model size, and just by sticking with few basic but extremely important rules that we will examine today. Okay, here we are. My story starts with a simple question to you. Have you ever wondered what makes your Power BI report so fast and powerful when it comes to performance? And when I say powerful, I mean that it is able to perform complex calculations over millions or even billions of rows in a blink of an eye. Maybe you wondered but couldn't find the proper answer. Perhaps you were just seeing the tip of an iceberg. So today we will discover what is under the surface of Power BI, how your data is being stored, compressed, queried, and finally brought back to your report. And once we are done, I hope that you will get a better understanding of the hard work which is happening in the background, and appreciate the importance of creating an optimal data model in order to get maximum performance from the VertiPaq engine. Okay, going back to starting point, what is a VertiPaq? Again, you will need to wait for an answer. Before we come to it, we should mark the line between row store versus columnar databases. VertiPaq is a columnar database. As you can see in this illustration, columnar databases stores and compresses data in a whole different way compared to traditional row store databases. Columnar databases are usually implemented in large analytical systems as they are optimized for vertical data scanning. That means that each column has its own structure and is physically separated from other columns. Another important distinction in order to understand what is VertiPaq is to understand the difference between formula engine and storage engine. As you can see in this illustration taken from the book Definitive Guide to DEX from Marco Russo and Alberto Ferrari, formula engine accepts the requests and generates the query plan to be finally executed. Storage engine pulls the data out of tabular model and to satisfy this request, which is issued by the formula engine. Storage engine can work in two different ways. First one is a VertiPaq, this one, which we will talk about today. And the second one is a direct query. So basically, VertiPaq keeps the snapshot of your data in memory. And this data snapshot can be refreshed from time to time from the original data source. Frequency of data refreshment depends on your business needs. It can be every half an hour, 2 times per day, once per week. So it really depends on your specific business case. Today, of course, this part of the architecture will be our focal point. On the opposite, direct query doesn't store any data. It just forwards the query straight to the data source for every single request. We will also talk about direct query today, but without going deep into details. Formula engine represents the brain of Power BI and brain of VertiPaq. So as I already stressed, formula engine accepts the query. And since it's able to understand DEX and MDX also, but it is out of the scope of this session, it translates DEX into a specific query plan, and that query plan consists of physical operations that need to be executed in order to get results back. Those physical operations can be joins between multiple tables, filtering conditions, or aggregations, for example. It's important to know that formula engine works in a single threaded way, which means that requests to storage engine are always being sent sequentially. So let's reiterate once more through the whole process which occurs within formula engine. First step is that formula engine accepts the request, then it will process this request. After that, formula engine generates the query plan, and finally it executes the generated query. After that, once the query been generated and executed by the formula engine, then storage engine comes into the scene. Since it physically goes through the data stored within tabular model, which is VertiPaq, or goes directly to a different data source like SQL Server, for example, if you're using direct query, we can think of storage engine as the muscles of Power BI, basically. So when it comes to specifying the storage engine for the specific table, there are 3 possible options to choose from. These 3 options are import mode, direct query mode, and dual mode. We will talk about each of those modes in a few minutes. And one last thing to keep in mind regarding storage engine, as opposed to formula engine that doesn't support parallelism, storage engine can work asynchronously. Let's first briefly introduce import mode, which is the most common way to store the data when working with Power BI. That being said, import mode is based on VertiPaq, and table data is being stored in memory as a snapshot, as I already mentioned in one of previous slides. That snapshot of your data can be refreshed periodically, going directly to data source and refreshing your data model within Power BI. When you're using direct query mode, data is being retrieved from the data source at the query time. And that's important to keep in mind that data lives in its original source before, during, and after the query execution. Dual mode is just a simple combination of previous 2 of import mode and direct query. So that means that data from your table is being loaded into memory, but at the query time it can be also retrieved directly from the source. Since we work predominantly with import mode in Power BI, let's talk about this mode in more depth. as we drawn a big picture previously, now let me explain in details what VertiPaq does in the background to boost performance of our Power BI reports. When we choose import mode for our Power BI tables, VertiPaq will perform the following actions. It will read the data source and transform data into a columnar structure. Then it will encode and compress data within each of those columns separately. Then it will form dictionary and index for each of those columns. After that, it will prepare and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. How VertiPaq stores the data? As you may recall from the previous part of our session, two main characteristics of VertiPaq is that it's a columnar in-memory database. So VertiPaq applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. So it can compress data in this ID column in a whole different way than in this name column, for example. Compression is being achieved by encoding the values the values within column. But before we dive deeper into a detailed overview of different encoding techniques that VertiPaq applies, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model which also works under the hood of Analysis Services Tabular and Excel Power Pivot. Okay, let's examine now the encoding types which VertiPaq applies in order to compress data. There are three of them, so value encoding, then hash encoding or dictionary encoding, and run length encoding or RLE abbreviated. Now we will go into more details regarding each of these encoding types. First one is a value encoding, and this is the most desirable value encoding type as it works exclusively with integers and therefore require less memory space than, for example, when working with text values. How it looks in reality. Let's say we have a column containing a number of phone calls per day, and the values in this column goes from 4,000 to 5,000. What the VertiPaq would do is to find the minimum value, which is 4,000 in our example, and set this minimum value as a starting point. Then it will calculate the difference between this value and all the other values in the column and store this difference as a new value. If you take a look at our example, in this imaginary case, we managed to save 3 bits per one row using this value encoding. And yeah, at first glance, 3 bits per row might not look like a significant saving, but just imagine that this fact table has, for example, few hundred millions of rows or even billions of rows, and just 3 bits per row times the number of rows, and I think you will start to appreciate the amount of memory saved. Hash encoding is probably the most used compression type by a VertiPaq. So using hash encoding, VertiPaq creates a dictionary of distinct values within one column and afterward replaces real values with index values from the dictionary. Let me show you examples so you will better understand how this works. So as you may notice, VertiPaq identified distinct values in the subject column, assign index values to those distinct values, and then built a dictionary by assigning indexes to those values. So it basically, in the end, it stored index values as a pointers to real values. I assume you're aware that integer values require way less memory space than text. So basically, that's the logic behind this type of data compression. Additionally, by being able to build dictionary for literally any data type, VertiPaq is practically data type independent. And that brings us to another key takeaway. No matter if your column is of big integer or text or whatever data type, from VertiPaq perspective, it's the same. So VertiPaq will create a dictionary for each of those columns, which implies that all these columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, if we assume that there is no big difference between dictionary sizes between those columns. So when someone tells you that data type affects column size, it's a myth. data type affects only dictionary size, not column size itself. On the other hand, number of distinct values within the column, which is known as cardinality, has the largest influence on column memory consumption. Finally, third algorithm, RLE or run length encoding, creates kind of mapping table containing ranges of repeating values, and that way avoiding to store every single repeated value separately. Again, if you take a look at example, it will help you to better understand the concept. So in reality, VertiPaq will not store this start column here. This is here just for the sake of clarity. It will store only number of counts. So, and it can quickly calculate where the next node begins just by summing previous values. And yeah, as powerful as it might look at first glance, RLE algorithm is highly dependent on the ordering within the column. So if your data is stored the way you see in our example, like here you have many repeating values, then next node begins with, again, many repeating values, next one begins, etc., etc. In those scenarios, RLE will work fine. But in other cases, when your data buckets are smaller and rotate more frequently, then run length encoding would not be an optimal solution. And one more thing to keep in mind regarding RLE, in reality, this is how VertiPaq applies RLE. So it first performs hash encoding and build a dictionary of subjects, and then apply RLE on top of it. So the final logic, of course, in its most simplified way, would look something like this. You can see on your screens. It's important to keep in mind that run length encoding occurs after hash encoding in those scenarios when VertiPaq thinks that it makes sense to additionally compress the data. So when the data is ordered in that way, that RLE would achieve better compression than using only hash encoding. Okay, let me just briefly iterate through the process of data compression for a specific column. So first thing that VertiPaq does, it scans the sample of rows from the column. And if the column data type is not an integer, it will look no further and it will use hash encoding. On the other side, if the column is of integer data type, then some additional parameters are being evaluated. If the numbers in that sample linearly increase, VertiPaq assumes that it is probably a primary key column and chooses value encoding. Then if we have value range, like we have in our example with phone calls per day, and if the numbers in this column are reasonably close to each other, like in our example with 4,000 to 5,000 phone calls per day, VertiPaq will use value encoding. On the other side, if your values in the column fluctuate significantly, let's say between 10 and 1 million, then value encoding would not make sense, and VertiPaq will apply the hash algorithm instead. However, this is important and just to keep in mind. However, no matter how smart VertiPaq is, it can also sometimes make bad decisions based on incorrect assumptions. So it can happen that VertiPaq makes a decision about which algorithm to use based on the sample data, but then some outlier pops up and it needs to re-encode the column from scratch. Let's imagine our previous example for the number of phone calls, and let's say that VertiPaq scanned the sample data and noticed values between 4,000 and 5,000 and chosen to apply value encoding. Then after processing, let's say 5 million rows, all of a sudden it found 500,000 value. It can be an error or whatever. Now what VertiPaq would do, it needs to reevaluate the choice and it can decide to re-encode the column from scratch using the hash algorithm instead of value encoding. And that would obviously has impact on the whole process in terms of time needed for reprocessing. Okay, so here's the list of parameters in order of their importance that VertiPaq considers when choosing which algorithm to use. First one, as already mentioned, is cardinality, or number of distinct values in the column. Next is data distribution in the columns. That means column with many repeating values can be compressed in more optimal way than one containing frequently changing values, because as you saw, a run length encoding algorithm can be applied on top of hash encoding. Then number of rows in the table, and finally column data type. As we already explained, it has an impact only on dictionary size. Now that we know what are the roles of formula engine and storage engine within tabular model, let's talk about materialization. That's one of the most important concepts for VertiPaq. So materialization is a step in the query execution process typical for columnar databases. Whenever formula engine sends the query to storage engine will literally physically go through the data and return an uncompressed table that contains requested data. The keyword here is uncompressed. This special temporary storage is called data cache. Data cache represents basically the materialization of the data that will be absorbed by formula engine. And it's important to know that both VertiPaq and direct query produce these temporary data cache structures. You should also be aware that there are two types of materialization: late materialization, which occurs in those situations when storage engine produces one single data cache with exactly the same cardinality as produced by a DAX query. On the other hand, when storage engine generates multiple data caches, or when one data cache has higher cardinality than one generated by DAX query, we are talking about early materialization. The main advantage of late materialization is that formula engine gets already prepared data, while with early materialization, it needs to perform additional stuff such as joining or aggregating, which implies that end users sometimes can experience slower queries in those circumstances. The key takeaway here is, whenever possible, push most of the workload to storage engine, as that will reduce materialization, and consequentially formula engine would have to cope with less complex tasks. Another important concept to understand in order to get the maximum performance from the VertiPaq engine is aggregations. Aggregations is nothing more than reorganized versions of the source table. So basically you can have multiple different tables related to same original table. By pre-aggregating data on different levels of granularity, we can help storage engine, we can help VertiPaq to work faster and scan the data in most efficient way. Applying different aggregations, we are reducing the amount of data. Basically, we are reducing the number of rows and columns. If you take a look at this simple example, my row table contains 7,346 records for chats within this specific period. But if I pre-aggregate data per date and per specific subjects, my aggregated table will contain 45 rows. So if my users need to analyze data per date and chat subject, having this kind of prepared table in advance will make the storage engine's job much easier. So instead of going to 7,346 rows, it will need just to scan 45 rows, and it can retrieve data much faster, of course. One more important thing to keep in mind regarding aggregations: they don't have any impact on optimization of the complex DAX calculations. So they are just enabling storage engine to work more efficient and reduce the time needed to execute the queries. Also very important to know is that aggregations work only with native columns from your data model. In other words, you can't perform aggregations on calculated columns. In reality, to be honest, you don't need to apply aggregations on each fact table. Of course, they make sense with VertiPaq only for extremely large fact tables, let's say with few hundred millions or even few billions of rows. Finally, be careful when you're creating aggregations, as each mistake can prove costly here, because if not defined in proper way, aggregations will produce incorrect results in the report. Moreover, having aggregations require additional effort for data model maintenance. Okay, I believe we laid a solid theoretical background for the things that will come now. It's time to get our hands dirty, as I promised, and see how all of this work in reality. This demo is not strictly related to VertiPaq, but more to general recommendations and best practices to keep your data model in optimal shape. Of course, in the end, VertiPaq engine will benefit from the fact that it has to deal with the optimized data model. So let's see what we as Power BI developers can do to make life easier to our friend VertiPaq. Maybe I mentioned this demo is based on a real use case which I faced during the last year. The problem was the size of PBIX file on our report server, as file size dramatically grown since the report had been first introduced. So I was involved in trying to find a solution. And just to stress one thing before we proceed further, for this demo, I've created 3 separate PBIX files, each of them representing one single phase in data model size optimization. I did that so we don't need to work on one single file and wait for Power BI to apply all changes during the process, as in some cases, as you may know, it takes a while to reload the data and recreate the data model. Okay, let me show you starting point. So I've just put simple card visual showing total numbers of records in my fact table in each of those files. So you can see that data accuracy has not been violated by applying various development steps. Here is our data model. It's quite simple. I removed a few dimension tables, so I have my, sorry about that. That's the beauty of live virtual presentations. My kids are in. So we have central, as a central table, we have fact chat table and just 2 simple dimensions. If we take a look at this fact chat table, it has around 9.3 million rows. So nothing special in terms of volume. Power BI should be able to easily cope with that. As I said, the main problem was that all tables were imported as it is. So just selecting table name and import mode. To be able to follow what is going on with our data model size, I will use DAX Studio. For those of you who are maybe not aware, DAX Studio is a really fantastic free tool created by Darren Gosbell, Marco Russo, and Alberto Ferrari. DAX Studio has a whole bunch of very handy and useful features that I would need another 60-minute session just to talk about them. In any case, if you're working with Power BI on a daily basis, yeah, just start using DAX Studio. Believe me, it will make your life much easier. So I will connect to DAX Studio directly from Power BI Desktop. And let me just do a brief introduction to some key things within DAX Studio. So once I'm in DAX Studio, I can see on the left-hand side, I can see all tables from my data model. If you're asking yourselves, what are these strange tables with strange names, local date table with bunch of characters, those are hidden date tables. We will come to that later, to that part to explain in details, but for now, for you now to know, it's hidden date tables automatically created by Power BI. If I go to Advanced tab and click on View Metrics, we will launch one of my favorite features within DAX Studio, which is the VertiPaq Analyzer tool. VertiPaq Analyzer tool will help us to see the numbers behind our data model and what kind of things VertiPaq applied in the background. So what VertiPaq Analyzer tool does it just collects data from various dynamic management views. So you can also use, let's say, SQL Server Management Studio to query your dynamic management views and get exactly the same data about your data model. But I guess you will find it in much more readable and understandable form within VertiPaq Analyzer. If we stay here in this Tables tab, we see all of our tables from our data model. And we can see the maximum cardinality, we can see the table size, column size, dictionary size, which types of encoding VertiPaq applied. But even more, if I click on this small arrow here next to a table name, I can see all those numbers broken down on a column level. So I can see what are my most expensive columns in terms of cardinality and memory consumption. And I can immediately spot that, for example, date TM start and date TM start UTC are the most expensive columns. I can see total, all these numbers I forgot to mention, sorry about that. All these numbers are in bytes. So we see that these columns take around 450 megabytes. You see which encoding type VertiPaq applied. So it's hash or value, depending on the values in the column, and how much space in terms of percentage specific column occupies in your table or database. And now if I take a look at this summary tab, I see that the total size of my data model is 1.86 gigabytes. So 1.86 gigabytes, that's the starting point. And let's go back and try to optimize this data model a little bit. So as I already mentioned, we have two date time columns going to second level of precision. This one, date TM start, is just a time when chat started in original time zone, and this one is converted to UTC. So in any case, I don't need both of those columns in my data model. I will keep UTC value, and then if I need to do some calculations within report itself, I can do that writing DEX instead of storing both of those columns with high cardinality in my data model. Also, source ID and chat ID, both columns have cardinality, maximum possible cardinality, as those are unique values. Chat ID is just a surrogate key from data warehouse, and source ID is a primary key from the source system. So I will get rid of this source ID. In any case, I don't need both of them. Also, few more columns, very expensive, session referer and referer, both text types and with high cardinality, more than 1 million. I checked with my users and they don't need those columns for any kind of analysis. So why should we import them at first place? Also, last edit date is just an information when the record was last time updated in data warehouse. So I will go back to my Power BI desktop file and go to transform data and get rid of those columns. So let's make life easier for our friend VertiPaq, so he has to deal with less data. Okay, I'm in my fact table, so I will remove date TM start column. Then the next one is referer, session referer, also source ID, last edit date, and finally chat variables. So I will just remove those columns from my data model as they're not really needed there. Let's wait for a few seconds for Power BI to apply those changes. Let's hope that it will not take so long. Yeah, it was fast. Let's go again to DAX Studio, and if I refresh this view metrics, I can see now that my data model size is 660 megabytes. So we managed to reduce, we shrink 2/3 the size of our data model just by removing a few unnecessary columns. And VertiPaq will be grateful for that. Okay, so true to be said, there are some more columns here that could be dismissed, but I want to focus now on other techniques for data model optimization and enable VertiPaq to work with full potential. As you may recall from the previous part of our session, when I was emphasizing the order of importance of different parameters that affects model size, I mentioned that cardinality is number one. So number of distinct values within the column. The rule of thumb is the higher the cardinality of a column, so the more distinct values in it, it's harder for VertiPaq to optimally compress the data, especially if you're not dealing with integer values. There are multiple valid techniques for reducing the column cardinality, and the most popular one is column splitting. I'll share with you now a few examples of using these techniques, and let's go to SQL Server Management Studio and you will better understand what I'm talking about. First thing that we can do is using division and module operations to split column with high cardinality like this. So instead of column cardinality of 10, I have one column with column cardinality of 1. This one still has column cardinality of 10, but we saved some bits per row, eliminating those first 4 digits. In this example, of course, it doesn't make so big difference, but again, imagine that you have a table with, I don't know, 1 billion rows, and yeah, this will definitely bring some memory saving. If you're dealing with decimal values, you can split this column and store them separately, so value before and after decimal point. This way you will also reduce the cardinality of the original cardinality of the column. And finally, I think that's the most useful one. If you're dealing with date time data type, you can simply split date part in one column and you can split time part in the other column. This way, for example, if you know that the maximum possible number of seconds in one day is 86,400, so we know that this column can't have higher cardinality than this number, so 86,000 and something. And yeah, that can also bring significant saving. Just one important remark here: if we use the calculated columns to apply data model size optimization techniques, there is no benefit at all, as original column still has to be stored in your data model at first place before your calculations are applied. Essentially, optimization techniques should be performed on the source side, in most cases by writing T-SQL statement or within Power Query Editor. Of course, if you're writing custom T-SQL code and use native query to import data to your Power BI data model, just keep in mind that you should perform all necessary transformations and calculations in one single step, as the query folding would be broken if you use custom T-SQL query and afterward apply additional transformation steps in Power Query Editor. Okay, so I show you how this is done, and in my exact problem is the column date TM start UTC, which takes, as you see, 67% of my table. 67% of my table. The first thing I did here, I just removed time part and I left only date. In 95% of cases, having data on day granularity level is completely fine, and your reports will serve the purpose. However, it appears that in my exact case, that was not enough, and my users wanted to analyze data on hour level. So what I did, I just rounded chats. Let me show you. So all chats that started between 3:00:00 and 3:59:59 were rounded to a starting hour, which is 3:00:00. And once I did that, let me show you. This is another PBIX file. Let me connect to DAX Studio from this PBIX file, and I will show you the difference. So I'm going to Advanced tab, View Metrics, to launch my VertiPaq analyzer. And now if I take a look at summary, my data model size is 221 megabytes. It was 1.86 gigs, just to remind you. And now if we go to my fact table, I can see that now date TM start UTC column has cardinality of 32,000 instead of almost 9 million. And obviously that had an impact to data size. Instead of 450 megabytes, it's just 17 megabytes now. So that's a big difference. That's a big difference. Finally, one more thing that still bothered me, and while I was dealing with this, I was, posting something on social networks, and Davide, which had a keynote this morning, advised me that this chat ID column is completely unnecessary in this data model because it's not being used anywhere. It's just a surrogate key from data warehouse. Just to be clear, and I don't want you to jump into some quick and incorrect conclusions, we can't simply remove all of those columns. So this, for example, IP address ID, customer ID, product ID, those columns are are foreign keys. They're foreign keys, and they're being used as part of the relationships to our dimension tables. But chat ID column, as I said, is just a surrogate key, is not being used in any relationship or calculation. So one last thing that I did is I removed chat ID column completely, and I wanted to show you one more thing. You saw these, let me just show you once again, those local date tables here in DAX Studio. Those are automatically created date tables from Power BI. If you're not aware, I will go to File, then Options and Settings, and then to Options. And if I open Data Load, here you see this Time Intelligence property and Auto Date Time. By default, is being turned on. So when you leave this option checked, what will happen? It will create a hidden date table for every single date field in your data model. So if you have multiple date fields in your table of hundreds of millions or even billions of rows, your data model will be bloated with those hidden date tables. What's even worse, these tables search for the minimum and maximum value, maximum date value in your whole data model, and create date range between this minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, every of your automatically created data table will span until that date, even if you don't have any record in your fact table that matches that date. Just be careful and turn this off. Okay, so I turned that off. And let's wait a few seconds. Let's go to DAX Studio one last time to see how our numbers look now. Okay, I'm going to Advanced, View Metrics. Let's go. As you can notice on the left-hand side, we don't have any more. And that's one more handy feature of DAX Studio. In Power BI Desktop, you can't see those hidden date tables anywhere. But once you go to DAX Studio, you can see them on the left-hand side. Now they disappeared, and we don't have chat ID column. If I go to Summary tab, I see that now my data model size is 157 megabytes. So our friend Vertipack, instead of having to deal with 1.86 gigs, now has to deal with 10% of that. In full honesty, in 95% of cases, when you're performing data model size optimization, just simple removal of unnecessary and unused columns will be enough to get your job done. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction and yeah, you saw with the integers and date time types and decimal, of course. So using some of the techniques we just saw a few minutes ago. Okay, so to conclude, here is the list of general rules, or let's call them best practices you should keep in mind when trying to help Vertipack to work in most efficient way. First, keep only those columns your users really need in the report. Sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this one rule helped us to make really astonishing savings. Try to optimize column cardinality whenever possible. The golden rule here is test, test, test. And if you notice a significant saving from, for example, splitting one column into two or substituting decimal column with two whole number columns, then of course do it. But also keep in mind, that's important to keep in mind, that your measures need to be rewritten in order to handle those structural changes. So if your table is not so big, or if you have to rewrite, I don't know, hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense for you. Same as for columns, keep only those rows you need. For example, maybe you don't need to import the data from last 5 years, but only from last 2. That will also reduce your data model size and enable Vertipack to perform in more optimal way. As I said, talk to your users, ask them what they really need before blindly put everything inside your data model. aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things we are trying to achieve. If you don't need hours, minutes, or seconds level of granularity, then don't import them. Simply don't import them. Aggregations in Power BI and generally in tabular model are very important and wide topic, which is out of the scope of this session, but I can recommend some really awesome resources on the web, of course, from Marco and Alberto at sqlbi.com, and also a blog series on creative aggregations from Phil Seamark on dex.tips. Avoid using calculated columns whenever possible. Simply said, they are not being optimally compressed. Instead, if you need to do some kind of calculations, try to push them on a data source like SQL database, for example, or perform them using the Power Query Editor. Use proper data types. For example, if you need data granularity on a day level, you don't really need to use date time data type for your columns. In those situations, plain date type will be completely fine. And finally, disable auto date time option for data loading, as this will remove a bunch of automatically created date tables in the background, as you saw in our demo. Okay, that's it from my side. Looking forward to hearing your questions, if there are any.
As I always say, don't be shy. You can open your microphone or you can write in the chat.
I see the question pops up from GP. If I will read it. If I understood well, you suggested to remove the rows unique identifier. What happens removing the ID in context transition? Imagine that removing other column, you have duplicated rows. Removing rows unique identifier should be done only in those cases when you don't use that in relationships and you don't use for calculations. Only in those scenarios. If you use for anything else, you can think of kind of optimization if it has high cardinality. But if you don't have it in any relationship, if you don't perform any calculation on this column, I don't see I can't see point in keeping it in data model. Hope this helps. So as I said, just let me show you once again.
Any other question?
Those columns, so IP address, ID. This is also unique identifier, but those columns are foreign keys to dimensions, so we can't remove them, of course, because we will violate relationships. But this chat ID was just a surrogate key, so it doesn't have any meaningful value for calculations, not being part of relationships. So yeah, it could go away from model.